Welcome to my presentation on deep reinforcement learning in society, letting the genie out of the bottle. My name's Greg Carroll. Let's get started. Deep reinforcement learning, or DRL, is one of the most surreptitious and pervasive contemporary technologies today, yet few have little knowledge or understanding of it. Being the basis of self-learning systems, it will have the greatest effects on society and dramatically alter the way we work, live, and evolve. So this presentation will explore recent studies on the potential long-term societal effects on the workplace, individual rights, and the ethical considerations. It will argue that, contrary to popular belief, it can prove a betterment to mankind. To support this hypothesis, this presentation will explain what DRL is, how it works, and then look at the implications on society from a technical, moral, and ethical standpoint. Let me start with explaining how deep reinforcement learning works. Deep reinforcement learning, or DRL, combines two of the main AI components, reinforcement learning and deep neural networks, or DNNs. Reinforcement learning is a self-learning approach to exploring a complex dynamic environment where traditional rule-based can't. In reinforcement learning, an agent achieves a goal by allocating rewards based on the agent's actions. Like training an animal, when it performs the desired action, the agent gets a reward. Inversely, if the agent performs negatively, it's punished with a negative reward. Through hundreds of thousands of simulations, it learns what actions, based on what inputs, result in a positive or negative reward. It can then identify the optimum strategy, which is referred to as the policy. The advantage of DRL is that it learns from raw sensory input, images or sound, without needing vast amounts of historical data, which is inherently flawed and biased. DRL is also dynamic, which means as inputs change, the policy evolves. Today's reinforcement learning theory has its foundations in Richard S. Sutton's book, Reinforcement Learning, 1992. Unfortunately, with a large number of possible actions and states, the basic reinforcement learning policy computations soon became intractable. The breakthrough came in 2013 by combining deep neural networks to calibrate the policy, which allowed for high-dimensional environments. It also allowed for the use of video to capture inputs. This accelerated the development of robotics. Next came transfer learning, which uses previously trained models as a base and dramatically reduced the model complexity and training time. Then came parallel computing, which enabled multi-agent reinforcement learning, or MAL, that allowed models to learn dynamic competitive environments. For example, roads have to be shared with other users, and those users interfere with your original intended strategies. The latest advance is reinforcement learning from human feedback. A human expert now provides additional rewards or penalties to guide the agent towards the desired outcome. Reinforcement learning from human feedback provides real-world moral and irrational challenges to be faced, for which normal AI cannot cater. DRL may have its roots in gaming and robotics, but its ability to learn from raw sensory inputs and make decisions in complex dynamic environments makes it a powerful tool for a wide range of tasks. It can be used in any strategic problem. DRL has been applied to areas of finance to optimize portfolio allocations based on market conditions, in marketing to optimize online advertising campaigns, natural language processing on the basis of chatbots, and healthcare for optimizing radiation therapy plans for cancer patients, also in gaming and autonomous vehicles. So why has DRL been so successful? In an amazingly short time frame, DRL has become surreptitiously pervasive. From Siri and Alexa to medical imaging analysis to Google Maps, the technology is now embedded in many aspects of daily life. Its quick uptake is because it enabled Dieter Rams' 10 timeless principles of good design. It's innovative, randomly exploring environments. It's useful. By definition, it's outcome focused. Aesthetic, well, there are still some human components. It's understandable because it connects your initial state to an outcome. It's unobtrusive. Most people don't even know that you're using it today. Honest, Well, it has a very specific outcome and purpose. Longevity, because being self-learning, it evolves with use. Solves the full problem, well, that's really a design issue. Environmentally friendly, it optimizes time and resources. And purity of purpose, again, because it's outcome focused. DRL has the potential to revolutionize many industries and improve efficiency and productivity in numerous domains. However, there also is several technical and societal issues that needs to be considered when adopting DRL technology. Technically, DRL is still in its infancy, with many challenges that need to be overcome to make it more effective and reliable. One major challenge is the problem generalization. DRL algorithms are trained for a set environment and may struggle to generalize when environments change. Another is unintended consequences. DRL systems can sometimes learn to behave in unexpected ways, which leads to unintended consequences. This can be particularly dangerous in the application of such things as autonomous vehicles. On the societal side, DRL has led to job displacement. Automating jobs leads to unemployment in certain industries. Another issue is bias and fairness. Although less than other forms of AI, DRL can still have bias. The potential for racial or gender discrimination can develop through the design of the environments and selection of reward actions. There's privacy and security. As DRL is commonly used to deliver personalized service, sensitive information about individuals must be protected and secured to prevent breaches and privacy violations. In the longer term, there are moral and ethical considerations. From a moral perspective, DRL technology raises some important questions about responsibility and accountability. If a DRL system makes a mistake and causes harm, who is responsible? Is it the developer of the system, the operator, or the system itself? This raises important questions about the ethics of developing and deploying this technology. Another is the general concern of the dumbing of society, with humans abdicating thinking to machines. The more we let AI perform analytical processes, the less adept humans will become at it. DRL raises ethical concerns about the use of AI in decision making, particularly in sensitive areas such as healthcare and criminal justice. Does society really want machines to make life and death decisions, or what is right or wrong? Due to the random simulation nature of DRL, reproducibility of experiments and results is difficult, if not impossible. This is the cornerstone of integrity and reliability of solutions. Addressing these social issues requires collaboration between policymakers, industry leaders, and researchers to ensure that DRL technology is developed and used in a way that will benefit the whole of society. The pervasiveness of DRL will inexorably continue and will have significant impact on most industries. This is because of the biggest benefit. It provides the ability to personalize products and services. If a product can learn and tailor itself to the needs and methods of the user, it will become more in demand. This creates a commercial necessity for rapid competitor adoption. Most commentaries on the effects of DRL are negative, from its potential to exacerbate inequality and widening rich-poor divide. This pessimistic view fails to comprehend the positive effects of DRL. Yes, existing jobs will be lost, but conversely, increased productivity creates wealth, leading to more work and new jobs in other fields. This duality extends to all social, moral, and ethical challenges of DRL. The same cause of poor reproducibility provides serendipitous innovation. Contrary to embedding bias and unfairness, MAL has been used to develop equality and parity in tax policies. In bionics, the brain-computer interface enables societal inclusion for those who are profoundly disabled. Overall, DRL allows for more efficient and effective decision-making processes, automation, and improvement in productivity. However, it is essential to address the societal issues and ethical concerns associated with DRL to ensure that it is developed and used in a responsible and beneficial way. In conclusion, deep reinforcement learning technology is a powerful tool that will revolutionize most industries. The genie is truly out of the bottle. However, its use raises important technical, moral, and ethical issues that need to be addressed. It is important to develop and deploy DRL systems in a responsible and ethical manner, taking into account the potential risks and benefits of the technology. The two takeaways from this presentation are: 1. DRL is a two-edged sword that can either be a disaster for society or a blessing, but it's in the hands of humans to choose. 2. DRL will change society, and it's up to us to adapt or perish. To paraphrase Charles Darwin, it's not the strongest or the most intelligent who survive, but those who can best manage change. Thank you.